Did you know there's an area on Earth that is home to most of the planet's volcanoes and earthquakes? Hi, my name is Christopher Catisse, and I work at the University of Utah on a geothermal research project called Utah Forge. Today we're going to talk about the amazing region we call the Ring of Fire. The Ring of Fire surrounds most of the Pacific Ocean, like a horseshoe extending from New Zealand to Siberia in Russia, across to Alaska in the United States, and down to Chile. It is 25,000 miles long, and most of the area of activity is around 300 miles wide. It is home to about 1,000 active or dormant volcanoes, or about 2/3 of the Earth's total. It is also where 90% of the world's earthquakes occur. Why is there so much geological activity in the Ring of Fire? It's because that's where several tectonic plates meet. Tectonic plates are huge slabs of the Earth's crust that fit together almost like a jigsaw puzzle. These plates are constantly moving on top of the mantle, which is a layer of the Earth made up of solid and molten rock, located between the outer core and the crust. There are several different tectonic plates that have impact on all this activity, including the Australian, the Philippine, Pacific Plate, North American, the Juan de Fuca, the Cocos, the South America, the Nazca, and the Pacific Plate. Well, since the plates are constantly moving, they naturally collide, move apart, and slide against each other. The areas where they collide are called convergent plate boundaries. At these places, the heavier plates slip and sink below lighter ones. This is called subduction. When the plates move apart from one another, it's called extension. As subduction happens, the heavier plate slides under the lighter ones. When it comes into contact with magma, it starts to melt. Eventually, the magma forces its way through weak points in the crust, erupting as lava, ash, and gas. When the lava cools, it hardens and builds up layers of rock. Repeated eruptions over time build up the cones that mark the locations of mountains and volcanoes. When extension happens, the plates moving apart from one another allow magma to rise to the surface, creating new crust. The result of those tectonic plates interacting with each other over millions of years has led to the Ring of Fire. Where the tectonic plates don't subduct or extend, they can move horizontally past one another in opposite directions. These areas are called transform boundaries. The two plates can get stuck where they touch. Even though the two plates are stuck against each other in one spot, the rest of both of the plates still move, causing stress to build up. Eventually, that stress is released by the rock breaking or slipping. This sudden release of mechanical energy causes earthquakes. A plane of breakage or slippage is called a fault. You may have heard of the San Andreas Fault in California, which is a very active fault on the Ring of Fire. It is the result of the Pacific Plate moving north and the North American Plate moving south. But that isn't the only fault on the Ring of Fire, since faults can form at any plate boundary. In fact, the area is home to the majority of the Earth's faults. Do you know a famous volcano? Some of the most famous volcanoes in the world are found in the Ring of Fire, including Mount Fuji in Japan, Mount Pinatubo in the Philippines, Mount Krakatoa in Indonesia, Mount Shasta, Mount Rainier, and Mount St. Helens in Washington State, and Ojos de Salado in Chile. Over the past 150 years or so, some of those volcanoes have erupted in spectacular and destructive ways. In 1883, Mount Krakatoa in Indonesia erupted. It was one of the deadliest and most destructive volcanic eruptions in history. A black cloud of ash is estimated to have been 89,000 feet high. The explosion was so loud it was heard as far away as Perth, Australia, 1,300 miles to the south. So much ash was sent into the atmosphere that it caused what is called a volcanic winter. Around the world, the sky was darker for several years after the eruption. The weather was colder and wetter. Temperatures in the northern hemisphere dropped by nearly 1 degree Fahrenheit. Southern California experienced record rainfall. Over 38 inches fell in Los Angeles in a single year. When the eruption was over, 2/3 of the island was completely gone, leaving a shallow sea. But since this is an active subduction zone, new magma chambers formed under that shallow sea. Nearly 100 years ago, molten rock began to rise, creating a new cone-shaped volcano. The new island is named Anak Krakatoa, or Child of Krakatoa. Major eruptions of volcanoes associated with the Ring of Fire have also happened here in the United States. In 1980, Mount St. Helens in Washington state erupted. It was the first volcanic eruption in the contiguous U.S., the lower 48 states, since 1915. It was also the most disastrous in American history. The ash rose 80,000 feet into the air and fell across 11 states, as well as into Canada. It caused the mountain's glaciers to melt, resulting in a mudslide that traveled 50 miles. Adjusted for inflation, the eruption of Mount St. Helens caused over $3.5 billion in damages. As we see with Anak Krakatoa, these eruptions also create islands. Both the Hawaiian and Aleutian Islands are volcanic islands on the Ring of Fire created by plate subduction. In the case of the Aleutian Islands, the Pacific plate is subducting beneath the North American plate. As the heavier Pacific plate slips and sinks under the North American plate, it heats up, creating batches of magma that have erupted, forming volcanic islands stretching nearly 1,200 miles from Alaska to Russia. There are almost 60 active volcanoes in the Aleutians, marking the northern boundary of the Ring of Fire. As a matter of fact, the entire country of Japan was also formed this way. Volcanic eruptions aren't the only geological activities that define the Ring of Fire. It's also home to earthquakes, which occur along the faults at the different plate boundaries. In fact, the National Earthquake Information Center, a part of the United States Geological Survey, estimates that about 90% of the approximately 20,000 earthquakes that occur every year happen on the Ring of Fire. It is important to remember, however, that of those 20,000 seismic events, fewer than 100 cause damage. Not only does the area experience the most earthquakes, but it is also home to the largest quakes ever registered. On May 22, 1960, a magnitude 9.5 earthquake struck Chile. It is the largest in recorded history. Alaska, at the northern boundary of the Ring of Fire, is the most earthquake-prone state in the United States, experiencing a magnitude 7 almost annually and a magnitude 8 or above about every 14 years or so. In fact, the second largest earthquake ever recorded and the biggest in the United States was a magnitude 9.2 on March 28, 1964 in the Prince William Sound region of Alaska. Since it is not a coincidence that the Ring of Fire is located where the tectonic plates meet, it shouldn't come as a surprise that it is also one of the most geothermally active areas in the world. That is because the magma associated with tectonic activity heats up nearby rocks. When water is present, that heat is transferred from the hot rock to the water. And if the rock is porous, that hot water can percolate through to the surface in the form of hot springs, geysers, mud pots, and other expressions of geothermal activity. Just some examples include Lady Knox Geyser and the Champagne Hot Spring in New Zealand, the approximately 80 geysers in the El Tatillo geothermal field in Chile, the mud pots at Sulphur Works in California's Lassen Volcanic National Park, and both the Serpentine and Arctic hot springs on the Seward Peninsula in Alaska. Well, thank you for spending some time with me exploring the Ring of Fire. There's a lot more information available online about this amazing part of Earth. Oh, if you'd like to learn even more about geothermal energy and Utah Forge, visit our website at utahforge.com. Again, thanks for listening.